Question 13 says that the bearing of Ming field from Lenton is 156 degrees. Calculate the bearing of Lenton from Ming field. The bearing of Ming field from Lenton. Let me just actually take a... This is Lenton. This is Ming field. This is 156 degrees. They want us to find the bearing of Lenton from Ming field. So this is what we need to find. So we know that this is 156 and this first quadrant is going to be 90 degrees. So if we do 156 minus 90, that is going to give us 66 over here. So this part over here is 66, which means since in parallel lines, alternate angles are equal, this is going to be 66 as well, which means this entire would be 360 minus 66. 1 second. And 1, this becomes 5. 3 minus 6 is 9. So that is 294 degrees. That is your bearing of Lenton from Ming field. Then on a map, the distance between Lenton and Ming field is 4.5 centimeters. The actual distance between Lenton and Ming field is 9 kilometers. Find the scale of the map in the form of 1:n. So first, let's divide 9 kilometers into centimeters. So we know 1 kilometer is 1,000 meters. 1 meter is 100 centimeter, which means 1 kilometer would be 100,000 centimeters. So that means 9 kilometers is 900,000 centimeters. So now next step is to divide 900,000 by 4.5. Move the decimal, add another 0. So 45 divided by 9 million. So we know if we divide this by 9, so that's going to be 1 million. That's going to be 5, 5, 1, 200,000. So 1:200,000 is your answer. Question 14 is asking us to expand and simplify. What we're going to do is we're going to expand the brackets. 15x minus 10 minus 6x plus 9. Whatever term is outside the bracket that gets multiplied with everything inside the bracket. Collect the like terms. 15x and minus 6 are like terms. So 15x minus 6x is 9x. Minus 10 plus 9 is minus 1. Expand the bracket in part B, where we're doing 2x plus 3 times x minus 7. 2x times x minus 7 plus 3 times x minus 7. 2x squared minus 14x plus 3x minus 21. Collect the like term. The like terms in this case have minus 14x plus 3x, so that would be minus 11x. That is our answer. Next question says these are the first four terms of a sequence: 1, 7, 13, 19. Find an expression in terms of n for the nth term of the sequence. So if you notice, 1 turns into 7 by adding 6. 7 turns into 13 by adding 6, and 13 turns into 19 by adding 6 as well. So if there's a common difference, like if like a common number is being added or subtracted, what you do is that you always multiply that number by the end variable, which is going to be 6n over here. And let's assume that the nth term is 6n. So we try to find the first term, t1. We substitute n with 1. So 6 times 1 is 6. Now the first term in the sequence is 1, but over here we have 6, which means in order to turn 6 into 1, we need to subtract 5 from 6. So now let's make the thing again. So t1 would be 6 times 1 minus 5, which would be 1. If you check for the second term, 6 times 2 minus 5 would be 12 minus 5, which is 7, which means the nth term is 6n minus 5. Question 16 says, OMN is a sector of a circle center O. ON is equal to 20, and the area of the sector is given as 30 pi centimeter square. You have to find the value of x, which is the angle of the sector. Area of sector has a formula of angle divided by 360 times pi r square. R is your radius. So we're going to replace area of sector by the value of 30 pi. X is what we have to find. 360 comes as it is. Pi comes as it is, and r is replaced with 20. So now if we rearrange this and make x the subject, we get 30 pi times 360 over pi times 400, which is equal to x. 400 is 220 square. So the pi's get cancelled out, the zeros get cancelled out, and we know 4 9s are 36. 3 times 9, it is going to be 27 degrees. That is your angle. Question 17 says, the mass of the planet Saturn is 5.7 times 10 to the power of 26. The mass of the planet Venus is 4.9 times 10 to the power of 24. Calculate the difference in mass between Saturn and Venus. So 5.7 times 10 to the power of 26 minus 4.9 times 10 to the power of 26. Sorry, 24. Now what we will do is, since 10 to the power of 26 and 10 to the power of 24 have 10 to the power of 24 common between them, I'm going to take that outside. Inside the bracket, we will have 5.7 times 10 square minus 4.9. 10 square times 5.7 is going to be 570 minus 4.9. Now 570 minus 4.9 is going to be 1, 5, 6, 5. So 565.1 So 565.1 times 10 to the power of 24. Now this says standard form, which means the decimal has to be after the first digit, which is between 5 and 6. So if we move the decimal 2 places to the left, which would be 5.651, we will add 2 to the power as well. So it becomes 26 instead of 24. So your answer is 5.651 times 10 to the power of 26. Question 18 says rearrange the formula and make x the subject. So we have y equals to square root of x plus 2 over 3. So first step would be to get rid of the square root from the right hand side. In order to do that, I'm going to square both the left hand side and the right hand side. So that leaves us with y square equals to x plus 2 over 3. Cross multiply, 3y square equals to x plus 2. And then what we do is 3y square minus 2 equals to x. That is your answer. Question 19 is saying A and B are points on the circumference of a circle center O. TA and TB are tangents to the circle. Show that triangles OBT and OAT are congruent. Give reasons for each statement you make. So first you need to remember is that OB and OA are going to be equal because they're coming from the center and going towards the circumference. So this denotes your radius. Secondly, whenever a tangent is touching your circumference and your radius is also touching that tangent, the angle they make will always be 90 degrees. And since the tangents are coming from the same point T, that means these two are also going to be equal. So the reason for the congruency that I'm going to use is side, 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 because OT is also the same. It's going to be reflexive property. So we can use side, side, side. We can also use side, angle, side, because this side are equal, the angle between are equal, and this side is also equal. You could use either of them, and that would be correct. Then if we move to the next one, it says f of x equals to 10 plus 7x. We have to find the inverse. So first step is to replace f of x with y. It becomes 10 plus 7x. Right now, y is the subject of the equation. I want you to make x the subject. So first we take 10 to the other side. And what we have is y minus 10 equals to 7x. Then I divide y minus 10 by 7. Because we're trying to get rid of the 7 from x. So that x is subject. So what we have now is y minus 10 over 7 equals to x. Now what I'm going to do is I'm going to replace the x with f inverse x. And I'm going to replace the y with x. So it becomes f inverse x equals to x minus 10 over 7. And that is your answer for this one. Question 21 says the rectangle ABCD is mathematically similar to rectangle PQRS. AB is 12, BC is 9, PQ is 8. Find the shaded area. So if they're similar, what we'll do is that we will use the similarity ratio for areas. So basically, AB is similar to PQ. And if we square this fraction, that would equal to the area of ABCD divided by the area of PQRS. So if we find the area of ABCD, That's going to be 12 times 9, which is going to be 108 centimeters square. Then what I'm going to do is I'm going to use this ratio. So AB is 12 over 9 whole square equals to 108 over X, which is the area of PQRS. I'm going to write that over here. Area of PQRS is taken as X. So that's 144 over 81 equals to 108 over X. Cross multiply to make X the subject. And now let's simplify this. We know that 144 is divisible by 3, which would be, if we divide that by 3, we get 48, 27. We can still simplify 48, that's divisible by 3, so that's going to be 16. That's going to be 9. 108 and 16 are divisible by 4. Yeah, that's going to be 27. 108 divided by 4 would be 27. And that's going to be 4. 27 and 9 would be 243, and 243 divided by 4. 43 divided by 4. That is coming out as X. So divide 243 by 4, that is going to give us 60.75. I'm just gonna move this a little bit. Actually, yeah, I'm just gonna rewrite this so that we have some space over here. Three over 4, which is 60.75 centimeters square. Yeah, okay. So we have to find the area of the shaded region. Shaded region is going to be the difference of all of this. Actually, let's just move that above over here. Shaded region. So the difference of 108 and 60.75. 108 minus 60.75 will equal to 47.25 centimeters squared. That is your answer. Question 22 is asking us to factorize the following. So I'm going to do a factor by grouping. So I'm going to factor the first two terms separately and the last two separately. So y is common between 7y and 2xy. So y times 7 plus 2x. And between 6x and 21, we have negative 3 common. So again, 2x plus 7. We take 7 plus 2x common because 2x plus 7 and 7 plus 2x are basically the same thing. If they were being subtracted, then it would be different. But since they're being added, it doesn't matter which one is written first. 7 plus 2x times y minus 3 is your answer. 3a square minus 12b square. So we take 3 common first. That leaves us with a square minus 4b square. If you remember the rule difference of perfect squares, where a square minus b square equals to a times b, equals to, sorry, a plus b times a minus b. We're going to apply the same rule over here. A minus 2b times a plus 2b. That is going to be your answer for this.